So this will be equal to 20 divided by root 2, isn't it? So if you calculate it, you can see that it will come to be around 20 divided by square root of 2, will be something around 14.14 amperes. That is the value of the current for the RMS value of the current. Okay. So that's how you will do the problem. Okay. The solution is also given in the slide. You can see it. Whether things are okay. Yeah. In the previous slide, you see. Both ways it's okay. In the slide, if you see, it is 2000 pi t plus 60 and 2000 pi t minus 60. Now, the next slide, we are going to explain something about complex numbers. What is a complex number? I think you have already studied about complex numbers in mathematics, right? Complex numbers. So, a complex number can be written in many forms. The first form is called the rectangular form. Rectangular form, in which you write a complex number z equal to x plus jy, right? Well, you can say j equal to square root of minus 1, right? So you can say x is the real part and y is the imaginary part, both of z. So this is the rectangular form. Okay, this is called the rectangular form. Okay. Now you can have another form called the polar form or exponential form. That's another form. Polar form or exponential form. Okay. Is given by, you write the complex number z equal to r angle phi. Or else you can write it as r e raised to j phi. Both forms are actually the complex forms. Z equal to r angle phi or r e raised to j phi. Okay. So what is e raised to j phi? I think you have studied about that Euler equation and all in mathematics. E raised to j phi equal to cos phi plus j sin phi. Okay. So you can write r e raised to j phi equal to r cos phi plus j r sin phi, isn't it? So you can write z equal to r angle phi equal to r e raised to j phi equal to r cos phi plus j r sin phi equal to x plus j y. So you can say x equal to you can say x equal to r cos phi, and you can write y equal to r sin phi. Okay. And you can do the reverse thing also. You can write always r equal to square root of x square plus y square, and you can always write tan phi equal to y by x. Okay, that's how you will do the things. So you can write phi equal to tan inverse y by x. Is it clear? Okay. So there are three forms. I will recapitulate once more. You have the complex number in three forms. The first form is A, that is rectangular form. Rectangular form is given by z equal to x plus jy. And the second one, B, is given by the polar form, which is given as z equal to r angle phi. And the third is called the exponential form, in the exponential form you have z equal to r e raised to j phi, r e raised to j phi. Okay, so you can find out this r and phi like this: r equal to square root of x square plus y square, phi equal to tan inverse y by x. Okay, and you can find out x and y also from r and theta. You can write it like this: x equal to r cos phi and y equal to r sin phi. Okay, cos phi, x is equal to r cos phi and y equal to r sin phi. This is how you will do the conversion between the rectangular and the other methods. Now, in the next slide, we will have a graphical representation of this thing. So we'll study about the representation of a complex number. So we'll draw the x-axis like this. With x-axis, we'll draw the y-axis like this. Okay. And I will. This is 0. I will draw a line like this. The length of the line is given by r. Okay, the length of the line is given by r. Okay, and this angle is phi. Okay, and if you draw something, if you draw its coordinates here, this length is x, and this length is y. Okay, so you can write z equal to x plus jy, or else you can write it as r angle phi, right? Or else you can write it as r e raised to j phi. So all these things are represented by the same diagonal. Okay. Now in the next slide we will see something about the addition and subtraction of complex numbers. Okay, suppose addition. First we will study about addition and subtraction, right, of complex numbers. Subtraction is plus and minus. Okay. Suppose if you have two complex numbers, z1 equal to x1 plus jy1, which and it is given by r1. Okay, you can write it as r. Sorry, I can write it as r1 angle phi1. I have another complex number z2 equal to x2 plus jy2 is given by r2 angle phi2. Okay. So if I am adding both the complex numbers, okay, you have z1 plus z2. You can write it as x1 plus x2 plus j plus j phi1 plus phi2. That is addition. Now you can have z1 minus z2 equal to x1 minus x2 plus j into y1 minus y2. Okay. And you can have multiplication. You can write multiplication. This is subtraction. Okay. Now if you can go for multiplication, it's like this. You have multiplication given by z1, z2, right? Now you can do the multiplication like this, z1 equal to r1 angle phi1 and z2 equal to r2 angle phi2, right? So you can write z1 z2 equal to r1 r2, then you can write the angle is given by phi1 plus phi2. Similarly, if you want to do division, this is multiplication. Okay. If you want to do division, you can write it as z1 by z2 is r1 by r2 angle phi1 minus phi2. Okay. Now if you want to find the reciprocal, this is division. If you want to find out the reciprocal of some complex number, suppose if you have z equal to r angle phi, okay, then you can write 1 by z you can write 1 by z equal to 1 by r angle minus phi. And if you want to find out the square root of z, you can write the square root of z equal to square root of r. Then you have to write the angle like this, angle phi divided by 2. Okay. Then you have something called a complex conjugate. Okay, something called complex conjugate. Suppose if z equal to x plus jy, then the complex conjugate is given by z star equal to x minus jy. So this is the complex conjugate. Just call the complex conjugate. Okay. Then you have Euler's identity, something called an equation. Euler's identity is given by e raised to j phi equal to cos phi plus j sin phi. Then you have e raised to minus j phi equal to cos phi minus j sin phi. These are the Euler's identities. Okay. So I will conclude this particular lecture by doing some problem. Okay. Suppose if I have z1, this is an example. Okay. Suppose if you have z1 equal to 8 plus j16. Okay. Then z2 equal to 12 minus j3. Sorry, I write 3 better. 12 minus j3. Then what is z1 plus z2? You add the real parts. 8 plus 12, that is 20, right? You can write it as 8 plus 12 plus j into 16 minus 3. So it will come as 20 plus j 13. That's answer. Okay. Now what is z2 minus z1? Okay. So I write it as z2 minus z1. That is 12 minus 8, right? Minus 8 plus j into minus 3 minus 16. So we will get it as 4 minus j 19. That's the answer. Right. Now we will have to do another problem for multiplication and division. Right. The next slide we will do. Suppose if we have example, another example. Okay. This example, I am given z1 equal to z1 equal to to find out z1, z2. That is, actually, it's better that you convert z1 and z2 to the polar form, right? So you can write, you have to write z1 in the form r1 angle phi 1, right? So what is r1? R1 is square root of 8 square plus 10 square, that is 8 square plus 10 square. If you calculate it, it will come as 100 plus 164, that is something around 12.81, right? And if you calculate phi 1, that is tan inverse y by x, that is 10 divided by 8, it will be coming around 51.34 degree. Similarly, you can write R2 equal to square root of 5 square plus minus 4 square, and it will come to be around 6.4, and phi 2 equal to tan inverse, and write Z2 equal to R2 angle phi 2, right? Tan inverse minus 4 by 5, that will come around minus 38.66 degree, right? Now you have Z1 equal to 12.81 angle 51.34 degree, and you have Z2 equal to 6.4 angle minus 38.66 degree, right? Then we can write Z2 equal to 12.81 into 6.4 angle 51.34 minus 38.66, that is, okay. So it will be 82 angle 12.68 degree, okay. Now if you want to convert this into the rectangular, you can write the x value equal to r cos theta, isn't it, or phi. So you can write it as 82 cos 12.68, okay. So it will be 80. Y equal to r sin theta equal to 82 sin 12.68 equal to 80. So you can write this also in this particular form, 80 plus j18, that is Z1 Z2, okay. This also, both are same, okay. Equal to 82 angle 12.68. Understand? So in the next thing we will do the division. We will have the division is given by Z1 divided by Z2 equal to 12.81 angle 51.34 divided by degree 6.4 angle minus 38.66, right, 38.66. So it will be, that is, we can write it as equal to, we can write it like this. minus of minus is plus. 38.66. Yeah, so that will be coming around 2 angle 90 degree. Okay. Now we can convert it into the rectangular form. X equal to 2 cos 90 equal to 0. Y equal to 2 sin 90 equal to 2. So you can write Z1 by Z2 equal to 2 angle 90 equal to 0 plus J2. That's how you will do the division. So with this, I end this particular lecture. Thank you for listening. Inshallah, in the next class, we will discuss the next chapter.